Hello everyone. Are you curious about why 18650 lithium-ion batteries stop delivering current and how they do it? You're in the right place. In this video, we'll dive into this fascinating topic in detail. But first, let's take a closer look at the internal structure of lithium-ion batteries to better understand the process. The outer layer of the battery is the steel cylindrical case. Inside the battery is the electrolyte, a liquid or gel substance that allows lithium ions to move between the anode and cathode. At the center of the battery lies the mandrel, a central support structure around which the electrodes are wound. It ensures proper alignment and stability of the rolled electrode assembly. The cathode is the positive electrode made of lithium-based compounds such as lithium cobalt oxide. It stores lithium ions during discharge and releases them during charging. The separator, a thin microporous film that prevents direct contact between the electrodes while allowing ions to pass through. The anode, typically made of graphite, serves as the negative electrode. It stores lithium ions during charging and releases them during discharge. Together, the cathode, separator, and anode form the rolled electrode assembly. To ensure electrical insulation near the positive terminal, the battery includes a top insulation sheet, while a similar bottom insulation sheet protects the components at the base of the battery. The cathode tab is a conductive strip that connects the cathode to the positive terminal, enabling the flow of current to external circuits. Similarly, the anode tab connects the anode to the negative terminal, completing the circuit. Metallic foil, a thin conductive layer that acts as the current collector for the anode or cathode, facilitating the flow of electrons during charging and discharging. Bottom disc, a metallic plate at the base of the battery that provides structural support and a contact point for the negative terminal. Insulation layer, a non-conductive layer placed between the bottom disc and top disc to prevent electrical short circuits while maintaining structural integrity. Top disc, a metal disc near the positive terminal that serves as a protective layer, helping to maintain the battery's overall structure and providing a pathway for current. PTC, positive temperature coefficient, a safety component that limits the current flow when the battery overheats, protecting it from damage or failure. Top cover, the external cap that connects the battery to the device, allowing the flow of positive current and serving as the battery's positive terminal. Vent, a safety feature designed to release pressure and gases in case of overcharging or internal failure, preventing the battery from exploding. Gasket, a sealing ring that holds all these components together, ensuring the internal parts are securely aligned and protected from external damage or contaminants. So far, we have discussed the internal structure and components of the 18650 lithium-ion battery. Now let's try to explain why these batteries interrupt the current flow. This is actually a safety measure implemented by a mechanism called the CID. So how does the CID work and how does it interrupt the current? The CID is composed of the top disc, insulation layer, bottom disc, and metallic foil components as a whole. The CID operates by monitoring internal conditions such as pressure and current flow. In the CID assembly, the lower edge of the top disc makes contact with the metallic foil, completing the circuit and allowing electricity to flow. However, when internal pressure rises due to gas buildup or high current, the top disc bends upward, separating from the metallic foil and interrupting the current flow. By interrupting the current, the CID system prevents further damage and reduces safety risks. Now, let's explain the basic reasons why these batteries interrupt the current supply. One common cause is over-discharge. When the voltage drops below the safe limit, typically around 2.5 volts, the CID deactivates the cell to protect its internal structure. Overcharge is another reason. If the voltage exceeds 4.2 volts, chemical reactions inside the battery can become unstable, and the CID stops the charging process to prevent potential harm. Short circuits are another critical factor. If a sudden high current occurs, the battery may overheat. The CID cuts off the current in such situations, ensuring the battery's safety. 18650 batteries are designed to last when used correctly, thanks to these advanced safety features. Understanding the role of the CID and other mechanisms can help users handle these batteries more safely and effectively. That's it for today's video. We hope you found this breakdown of 18650 lithium-ion battery shutdowns and their internal mechanisms helpful. Don't forget to like, comment, and subscribe for more tech insights and tips. Stay safe and always handle your batteries with care. Thanks for watching.